So it's our final actual lecture of the course. Next week we're going to have a short demonstration about Pygame uh, and a couple of words about the final exam as well. I will show some examples of the exam questions from some old exams that won't be recorded. So if you want to see it, you need to be here. And but today we're going to talk about some more features of functional programming. And last week we started discussing functional programming. We talked about list comprehension uh, and about different properties of list comprehension, like filtering items and so on. And then a little bit about dictionary comprehension, which is basically the same thing, but instead of creating a new list based on a sequence, we're creating a dictionary based on an iterable sequence. And then another thing we discussed was recursion, uh, which some of you uh, found a little bit confusing, and this was something I mentioned last week that it can be a difficult topic at first, uh, and we saw some sort of a simple examples about that. And if you didn't find it fully understandable, it doesn't. This is don't take it too seriously. You will understand it when you start using it more, and it is a difficult concept to sort of understand at first. I went through the feedback and there wasn't much else. There was a question about difference between a function and a method, which I think it's a good question. It's something we've been discussing before, but it still might be a bit confusing. Uh, and the short answer to that is that a method is something that's defined inside a class, and that's uh, doing something with an object. So you're basically observing an object, or you're changing an object, changing the data inside an object with a method. And then a function is like an independent subprogram, something that isn't tied to an object, something we just define. So in short, in most of the time, a function is something that's defined outside any class, and the method is something you define inside a class. We also have static methods which are closer to functions than object methods, but those are still defined inside a class. Okay, then let's go to this week's topic. So let's start with sorting out something. So let's say that we have a list of tuples. Let's do something else. Something like this, for example. And so what happens when we sort this list out? Any ideas? So how does Python sort out this list of tuples? I don't know if you ever tried it yourself, but what do you think might happen? Yeah, exactly. It uses the yeah several correct answers. So when we sort it out, if you output the list, it sorts it out based on the first item in its tuple, which might be exactly what we want. But if we want to do something else, let's say that we want to sort this list out based on something other than the first item of its tuple, or we have something more complicated, like a list of our own objects or whatever, and we want to sort them out differently than just like the basic idea of sorting them based on the first item of a tuple, or if we're sorting a list, not sorting them based on a, let's say that we want to sort a list of strings based on their length or something like that. And now what we can do is we can write our own value method, sorry, function, value function. just talking about methods and functions. And the idea for this one is that we need to write a function which gives us the value of a single item, and then we can use that value to sort out the list of tuples. So basically, we write a function that receives a single tuple if tuples are what we are sorting out, and then it returns a value which Python uses to sort this all out. And let's say that we want to sort these tuples based on the second item of each tuple. So what we do is we return the second item of a tuple. So this function itself is really simple. It receives a single item and then it returns the value which is used in sorting. And now what we can do is we sort this list and now we add an additional parameter which is called key. And for this key parameter, we return no, not return, but we pass a function, the value function that is to be used to determine the value of each of these items. And we do it like this. And now this is something new, and this is something we're going to talk about today a bit more, a lot more actually. The idea that we can pass a function to as a parameter. So we're not calling this function, but we are passing it as a parameter. So we're telling Python to use this function to determine the value for each of these items before sorting it out. Get rid of the spaces. And now we can see what it looks like. So when we sort it like this, we can see that now it uses the second item in each tuple to sort out the list. So if you look at the second item, it's like 2, 2, 2, 3, 4, 5. So it's in ascending order. So something like this is really handy if you want to customize your sorting. And we can do whatever we want in this value method. So, or for example, we could return the sum of these items. And now Python sorts it based on the sum of each of these items. So the first item, for the first item, the sum is the smallest 3, and for the final one is the largest, 5 plus 2, so 7. So it's easy for us to customize the sorting however we want to. Let's do something a little bit different to show you. Just going to save that and show you another example. Let's have a list of names. And let's say that we want to sort this. If you sort, you know how it goes. If I sort this name, list of names, then it sorts it based on the sort of in alphabetic order. What it does, it actually sorts it based on the order of those characters in the current character set, but it's usually quite close to an alphabetical order. And let's say that we want to sort it out based on the length of these names. So we want to have the shortest name first, and then the longest name as the final one. And again, what we can do, let's define this value. It doesn't really matter. We can actually, in this case, we don't even need to define any functions because there is already a length function, len function, which we can use for this one. So we just set the key to be the len function, the existing len function, and now it's sort based on the length of those names on the list. So we just need to define a function which receives a single item as a parameter and returns a value which can be used to determine the order of the elements. And if we see how this value function is used, we can add this additional print statement and see what happens here. And you can see that Python actually calls it for each of these items before sorting it out. So this really happens. Python does use the function and it calls it for each of these items, and then it gets the value for each of those items, and then it uses those values to sort out the list. So this function itself has a little value. I mean, returning something like a list of the items in a tuple, or especially let's do something even more simple. Let's say that we're returning the second item in each tuple. The function itself isn't that useful. So there are things we can do to sort of try to overcome this. So let's say that we are writing a sort, a function for sorting out the list. What we can do is we can define this value function inside this sort list function. Let's get rid of these. Let's say we can also use the sorted. So this key parameter works for both sort method and the sorted function. So it's possible to use it, of course, possible to use it for both or use it with both. So this one should work. So again, it's sorted based on the second item in each tuple. And what we did is that because we don't really need this function anywhere else, this value function, as I said, it isn't really that useful outside this context. Because if you want to get the second item from a tuple, you can easily do it by using the square brackets notation instead of writing a or calling a separate function for that one. Uh, so we write it as an inner function or like a nested function inside this other function. And it means that this value function is only callable inside this function sort list. And you can, of course, do this with any function, but usually I would say that avoid this. Usually I would say that functions are sort of independent pieces of code that needs to be callable wherever in your program, whether it's in main program or inside any other function. But if you have a function that has no value outside this context, like this one in here, then I think this is a good idea to define it in here because it no one else needs to call this function. It's only here because we need to provide a custom function to this sorted function in this case. So that's the only reason why we need to define it. But other than this, I would be really sort of cautious on whether you want to write a function inside another function. But again, this is something that is possible in Python. You can write these nested functions inside other functions. Okay, let's see. We talked about this, and okay, then even this is a little bit sort of okay, sort of too much in some cases. Uh, and if we have a function that really doesn't have any other value than using it, for example, in sorting out something really simple like this, we can define it as an anonymous function, something called a lambda function, and we can use the lambda statement to define the function. And the idea of a lambda statement is that the syntax is here, or lambda expression, sorry, of course, uh, is that there's the keyword lambda, then there are the parameters, there's a colon, and then the expression which uses these parameters. Uh, and it needs to be a single expression. There can be any number of parameters, but single expression which is then returned. And the basic idea of this lambda function, anonymous function, is that, as the name implies, it's anonymous. It doesn't have a name, so it cannot be called outside this context where we use it. And it's meant for cases like this where we need a function uh, for something, but we only need it for that one specific reason, and we don't really need to call it anywhere else. So how can we use it? We can use it, for example, in sorting, say values dot sort, and then we define again the key. And instead of using like a function we define with the def keyword, we can just state that lambda, and then this gets a single item G and returns the second item from that tuple it receives as an argument. And let's try it out. And now we see that it actually does what it's supposed to do. Or if you want to change it, we want to sort it by multiplying the items, for example, then we can use it for this one as well. So now it calculates the multiple or the product of these items in each of these tuple. And the smallest one is again the first one, and the biggest, largest one is the final one. So that is really useful when there's a case like this where we sort of don't really need the function for anything else. And so we don't want to define it by using the def keyword, but instead of just do it like this. The thing about Lambda is that it does create a function that's callable. So we could do something like this as well. What should I do? So this is something that is possible in Python syntactically. So we can define a function like this, and then we can use it. So what does this output? What do you think? Yeah, it outputs 30 because it calculates the value of 10 plus 20. But again, this is something we can do, but we're not supposed to do. And to so in Python's documentation, it does explicitly state that you're not supposed to use lambda like this. So if you want to define a function sum of items like this, which you will can call later, you're supposed to do it like this, like we've been doing before since week 3 or 4, whatever it was. So this is the proper way to define the functions. How we've been doing it before. So lambda is only meant to be used in cases where it is where you want to create an anonymous function and you don't want to call it later anywhere. So you're not supposed to assign it into any variable or any like you're not supposed to give any name to that function. So that's like misusing the whole idea. And the basic idea is that this is, I think, way more readable, and this is the like the normal way of defining functions, and it's easy to find the function definitions in your program when you do it properly, like we've been doing before. So lambda is not meant to be used like this. Let's get rid of it. Okay, let me show you something else. Let's have again. Let's get back to student class. Using it a lot, so let's use it once more. I'm just again writing the short version for this one. And let's add the REPR method for this one as well. And let's return it by using f-string, and let's do it properly. Sorry. So this is supposed to return a string which can be used to create another similar student. So let's have the name, and let's not L, although it's close to Christmas. Self.credit, so like this. And then let's create a couple of students. 2 more. Give me a second. Okay, then let's have a list of students. Let's add all these student objects into a list. And now a couple of weeks ago, we discussed the idea that if we have a list of objects, and if we define the TT or LT methods, which enables us to compare the items, that also enables us to sort the list of students. And that's useful. That's useful for other things than sorting as well, but that's useful for sorting too. But there are quite often there are cases where you want to sort a list of items based on different criteria in different places in your program. So you might have like a list of students and you want to sort them by name, and then later you want to sort them by credits, and then later by something else if you have a more complicated object. And this is really common, and it's like a basic thing you do with Excel or Google Sheets or something like that, that you have a spreadsheet and then you sort it based on different columns on different times because you want to search for different information or want to compare them based on different values or things like that. Uh, so we can utilize this in sorting as well by using the key parameter. So if we want to sort this by a name, we again create a lambda expression. So it's a student, or we can actually write student, and then what we do is we return the name of the student object. And then what we have is a list of students sorted based on their name like this. So in alphabetical order. And if you want to change this, if you want to sort the list by credits, we can then change it to be credits and again sort it by that one. And however we want to do it, whatever property we want to use, it's easy to change it inside the program. So we can sort it based on different values in different places in our program. Uh, and this idea, actually one thing I sort of forgot. We can also use this key parameter with other Python's built-in list functions. So for example, we can use it for max as well. Let's do this one first. So what does the program output? Which student does it output? Let's say it like that. Yeah, it's going to be Arnold because Arnold has the highest number of credits, so the most credits of all these students, 98. And we do something. We can also use it with min function, of course. So this is again quite handy. This gives us again Arnold because he's also that's also the student first in the alphabetical order, and so on. So this also works with min and max functions. Now, basic idea of passing functions as arguments works in Python in other occasions as well. And so we can all, for example, we can write our own function if we want. Uh, so we can do something like this, which may look a little strange at first. So we have a function run, which receives an operation and then a parameter. And what it does, it performs that operation. It passes this parameter to this operation and then outputs the result. Meaning that if we call it something like this, what does the program output? Yeah, outputs 5. Exactly, so it passes this len function to this parameter operation, and then this hello string hello as a parameter, and then it passes inside this, it passes this parameter value hello to this operation len with, and then the length of that string is of course 5, so it outputs 5. And again, this works with any function. So we can do something like this. And this of course outputs 10 because the maximum of this list is is then okay. One more. What does the program out? You're doing great today. It's ABC, ABC again. The function we pass is this lambda function, this anonymous function we create when we call this, and then the parameter is ABC, and what it does, it multiplies this ABC times two because that's what happens inside this function. Now, this is something that may seem like a trick, like something that's hardly actually usable. And in most cases, it isn't necessary in most programs, but there are cases where something like this is actually useful. And I'm going to show you one. It requires a little bit writing, but bear with me on this one. Uh, so what I'm going to do is I write a function. I used to, so I'm thinking, well, yeah. So what it does, it reads all the lines in input file and then writes them into output file, and then it only writes the files that satisfy this filter operation we have in here. So how we can do it? Let's open both files. Okay, it wasn't that big program. So what we have, now we can test this out with something, and for this I have this. Yeah, where can I move this? Somewhere over there. Sorry, the zoom controls are always on zoom somewhere in front of everything they're not supposed to be. I have this list called nimet.txt, which is of course in Finnish, but the names are in English. So this is a list of names I generate. I probably ask ChatGPT to generate these for example purposes. And let's say that we want to copy all the names that start with letter A into another file. So what we can do is we call the copy lines. We define it was none, and the output file is called names begin with A, and then we define the function. And this function isn't that complicated. We can create with a lambda expression. So lambda is a single row, and then we can state that R begins with, and then letter A. And begins with this is a string function we've been may have been using before, but it's true if this string begins with A, or we can just use the fact that the first character is an uppercase A in this case, which also works. So let's see if it works. At least it creates a file with name, call it name begins with A. And if we take a look, yeah, there are all the names now, that all the lines containing a name that begins with an A. And why is this useful if we only need to do this? If we only need to copy the names starting with a letter A, we can of course write a function that does exactly that. But if we need to perform this similar operation with different kind of filters, then something like this could be useful because we can do something else as well. Let's let just copy this function call, and let's say that we want to copy all the names that uh, let's say all the names where the surname begins with W. And this is a little bit more complicated, but we can still write it as lambda expression because it's we split it, and then the second item is the surname, and then the first character is the at zero at index zero, and then let's have a W with that one, and let's call it surname begins W. And let's try that out. And now we have a list of names where all the surnames begin with W. And you can see that something like this is quite expressive. It's possible to do sort of a lot of similar kind of things with the single function in here instead of because the alternative for this one would be just to copy and paste the same function, and we could have a function like copy lines with first name starting and copy lines with surname starting and whatever. But if we have a lot of these different rules, let's say that we want to have the names that are longer than something or shorter than something or whatever rules, like a lot of similar rules, then having this function where we can pass the filter operation, the function that does the filtering, can be useful. And of course, for this one, we can also define the function ourselves. We don't need to use the lambda expression because we are just passing a function. So if the function is more complicated, something that's difficult or impossible to return as a result of a single expression, then doing something like this, or then defining the function by using the def keyword is definitely a good idea. So then we can just use it in here. And this is something I've been using, actually using in some occasions where I had a lot of data and I needed to filter the data out based on different criteria. And if I see just write a single function which does the copying to a result file and then just pass a different filtering operations and then use those here. Okay. Uh, Now the basic idea of using or passing a reference to a function in Python actually works with any function, and it doesn't need to be. You don't need to pass it as a parameter. So you can do something like this. I'm not saying that this is a good idea, but so again, simple. What does the program output? Yeah, it outputs one. One is the minimum of this one. And what it does is uses the built-in min function, but we just defined this name minimum. It's a variable, but it's a variable that references a function. So we can use this to call this function. I please don't usually this is not a good idea because we all know what the min function does. If someone is using the min function in the program, it's easy to know what it does. If we use like an alias for that, then we need to locate this code in the program to know what the minimum does, unless it's really obvious. But there are occasions where I say something like this is sort of useful, like for example, let's see that we are importing the datetime function and we want to refer to datetime. Can even call, well, let's call it just DT. And then writing this datetime a lot is sort of can be irritating. So instead, we can then use this alias DT to, for example, determine what is the current time or something like that. And especially, but if you're doing something like this, then please do the assignments right after the when you've done the import statement, so it's easy to locate in your program and so on. And even in this case, it's a good idea to consider whether this makes your program a lot more difficult to understand or whether it's a good idea. And of course, this means that we can do whatever we want in Python. You can do this, and we all realize that this is probably not a good idea unless you're doing like practical talk to your friend's code or something like that. Even don't do that either. But but yeah, But this is possible. We can assign the max function in the min function, and after this one, if we try to take the minimum of 153, then it tells us the minimum is 5, which is of course isn't, but it is in this case because we change the minimum to be the maximum. We can even do the min and max equals max and min, which now switches the functionality of these two functions. I we were talking about discussing this in the Finnish version of this lecture, and we're thinking that there could be like some case where you want to change the behavior of these for some reason. You're doing something like a mathematical or some other kind of program where you want the minimum and maximum to work exactly opposite than they usually do. But I would still say that this is something you probably don't want to do. But it is possible in Python because you can assign a function into another function and then like referencing it by using a different name. Okay, this is definitely if you want to mess with someone else's program, this is probably a good idea. Please don't, as I said, please don't do it. Let's see, we talked about a lot of things. Lambda expression, min and max function as an argument. Okay, then let's talk about something else. We have a couple of things in this final lecture we need to address, and something another thing is something called a generator, which is again something about functional programming. Uh, and the idea of a generator is that it resembles a function, but instead of returning, or it does return a value, but in addition to returning a value, we can go back to that function and keep on executing it for on where we left off. So let me start with something simple. Let's call the start and end like this. And for this function, let's just write a simple for loop which goes from start until end, and let's include the endpoint as well. And then instead of returning anything for generator functions, we use the command yield. And now how this works is that when we create a generator, let's call the values, and let's see that we're interested in values between 1 and 10. And now if we output this gen variable, it only outputs the information that it's a generator object and then this memory address somewhere. So this is not really useful. But what we can do is we can ask values out of it. So we can state something like, we can use the next function for this one, the built-in function. So what we can do is we can, for example, get the first 3 items from the generator. We get 1, 2, and 3. Of course, if we initialize this with something other than this, then we get the first 3 items that generator are 10, 11, and 12. And so the generator is great for cases where you want to get some items, some values from a sequence, and then you want to do something else, and then you want to get more values from a sequence. So for example, let's say that you want to get like these running ID numbers in your program for whenever you're creating objects. And you can have a generator where whenever you need the next ID, you can ask for the next ID number. Something like that could be useful. Uh, the generator is an iterable object, meaning that we can say that for I in 10 and then output I, and then we get all the values from that generator, in this case, the values between 10 and 20. So in this case, it really depends on what we're doing in here. But whether it's useful to use a generator, then just say that for I in range and then create it yourself. But if it's more complicated, then this can be still can be useful. But the basic idea of a generator is that yield is like a return, and but we can return to that function after using it once. So when we go back to it again, then it remembers where we were at last time. So it gives us the next item in the sequence. Question: what is the scope of generator what do you mean by scope in this one? I mean, this is scope in a sense that this is visible wherever this variable 10 is visible. That is like the scope. The generator itself is just an object, and it depends on where we assign it. If it's this variable 10, then it's visible wherever we can use this variable 10. So we assign the generator into variable each time. Let's do something else. Not return, but yield. Do it like this as well. So let's say that we have a generator that keeps giving us all the vowels in a string we use to initialize the generator, and we can use it for like this. Let's again create a generator, call it wow. So if you do it, if you use it in for statement, again, it keeps giving us all these vowels in the string one at a time, or again, we can take them one at a time by using the next function like this. So then it gives us the first four vowels in a string like this. Now, a couple of things you need to realize about generator. The first one is that you can't ask the generator to give you more items or more values than there are. So if you try to get 4 items from a generator initialized with a little and there are only 3 vowels, A, I, and E, then this is an error. It's well, it is a sort of an error. It halts your program, but the generator what it does, it gives you this stop iteration, uh, which you as may remember we used when we wrote our own classes, which can be iterable. So we used this in iter and next methods. So what we can do if you want to make sure, we can use the try except for this one. And usually we don't need to even do anything with this one. Let's just use pass for that one so we don't get an error. It gives us the first 3 items, the first 3 values from that generator, and then when the stop iteration happens, then we can move on with the program. Generators are a sort of a Python-like thing in a lot of sense. There isn't anything equivalent, at least anything simple equivalent in a lot of programming languages. And the thing about generators is, from my own experience at least, that it can be really useful in some occasions, but it's also something that's sort of difficult to remember that it exists. At least for me, I don't know why is that. There are I've done a lot of times I've been writing something and I've done something in my program and then realized that okay, a generator would have done this so much would have been so much simpler way to do this. So I think it's a good idea to try to master it at least a little bit. Can you master something a little bit? I don't know, maybe. Uh, at least know a little bit something because it can be useful. Another thing about generators is that it can be also, you can create a simple generator with this comprehension syntax. And now the last time we talked about a list comprehension and a dictionary comprehension, and I briefly mentioned that there isn't a tuple comprehension. The tuple comprehension syntax is reserved for generators. And this means that if I do something like this, again, this is great if you have a simple expression which you want to use. Uh, so let's say that x to the power of 2 for x in range and then go from 1 and to 11. And what this does, again, if you output it, it displays it's a generator object. And what we can do, again, we can iterate through this if we want to get all the values in the generator, or we can use the next for this one if we want to just get a couple of items, a couple of values from the generator, and so on. So this is useful if the generator is something you can implement with a single expression instead of doing anything more complicated. And a lot of times you can. Again, a lot of times you need to think about whether you want to use a generator for this one, or whether you want to just create a single but again, a good thing about this one is that you don't need to. If you do this with list comprehension, then it actually creates a list with all those values. And if you don't need a list of those values, but you just need all those values at once or values once, then you can save the memory, especially if you're generating like longer sequences. One final thing about generators is that they are only usable once. So when you create a generator, and let's do a little bit shorter one. Let's do just like 4 items. You can only iterate through a generator once. It isn't an error if you try to do it again, but once we've gone through all the values in a generator, then there's nothing left in there. It's like you can only use it once. If you want to reuse it, you need to reinitialize this generator object. Uh, yeah. Okay. I think that's it about generators. Then couple of more words about functional programming. Uh, Something we've been discussing last week and the lecture last week and also this week. Uh, but the basic idea for functional programming is that it's a programming paradigm where the changes in state are avoided. So if you have a pure functional program, it means that we are not using like conventional variables or anything like that, but we are typically like nesting function calls and using anonymous functions and so on and so on. So we don't really need any names for this. Now Python has some functional features. Python is also this like a mixture of different programming paradigms. We have this procedural and object-oriented paradigms which we've been using before and imperative as well. Uh, and now we're using the functional features, but Python isn't like a pure functional programming language in a sense that it's really difficult to write Python programs without using any state. At least it gets really tricky and difficult to comprehend probably. But there are some functional features which are useful, like list comprehension is definitely something, and lambda expressions are definitely useful and so on. Uh, and I'm just going to show you briefly a couple of functional functions uh, which are can be useful for some occasions. And the main reason why I want to show you this is that these are again encountered quite often in Python programs. I want you to understand what they are meant for. And the first one is called map, which performs the given operation for all items. So let's say that we have a list of numbers, and we want to multiply them all by 10. We can do this with map, and what we do is we first perform the operation, and then we give the sequence. And now what this does, it creates a map object, which we can see in here, but that's an iterable object. So we can do something like for item, and then output the item like this. What would be another option for performing the same operation? Something we've been using before. If you have a list of items, you want to multiply them all by 10. Yeah, list comprehension. So you could perform the same exact operation with list comprehension. And now the thing about this one is that they can both be useful, but usually people are probably more accustomed to using one than the other. Uh, Although there are some occasions where when the other one is can be probably a bit more readable. I'm not really used to using these functional functions in Python, except the final one, which can be useful, which I talk about in a minute. So I probably would use a list comprehension or a generator for a case like this. But it's a good idea to know what it does, regardless. And again, it doesn't create the actual list, so this can be useful in a sense that you may save some memory if you're working in like a tight environment or tiny environment, or if you're working with really huge lists or something. Another, I'm going to go through this quite quickly because I just want to get the idea. Another example is the filter, which again you might find similar. So if we want to get the even items from the list, we can use the filter. And again, we define the operation, whether it's an existing function or a lambda operation, and values. And this one gives us, of course, the all the even items from the original list. Again, we can do this with list comprehension, as you know. If we just add the if statement or if part at the end of end of list comprehension, we can filter out whatever or only include the items we want to include. So this is really similar to that one. But this final one is a little bit, I don't know, these are useful. The filter map and filter functions are useful, definitely. But the final one is a little bit more difficult to implement with whatever tools we learned before. And it's called reduce. And for some reason, it was usually part of like core Python. You didn't need to import it, but for some reason it was moved to a library called functools, like a couple of versions. In version 3 point something, can't remember. Uh, or might have been just version 3. Regardless, now you need to import it if you want to use it. And the idea of a reduce is that, let's again have the same values. We can use this to combine these values into a single value. So how do we use it? We again give the operation, and now we need to have two parameters for this one. And we have the values, and then we have the starting value if necessary. If the starting value cannot be determined based on these alone. So what it does, it actually, now in this case, it just calculates the sum of all these items. And of course, we can combine them with any way we want to. We can use the multiplication. What's wrong with this reduce statement now? Yeah, the 0 is a bad starting value when we're multiplying items, so let's start with 1 instead. So now we perform, this is actually the factorial of 7 in this case, but it combines the values by using this operation. Or what it actually does, if we are talking about it in detail, is that it combines this value y into this sequence x by using this operation here. So in practice, it usually just combines the items based on this operation one at a time. So it first multiplies 1 by 2, and then multiplies that 2 by 3, and then multiplies that 6 by 4. And so each new item is combined into this list by using, or into this value by using this operation in here. So from these three, the reduce is definitely I would say it's the most difficult to do by with a single expression by anything else. You can, of course, you can write a simple for loop that would do the same thing. That's like 3 lines of code. If you want to do it like that, but reduce can be useful because you can do it as a single expression, and in some cases that might make your program, well, at least shorter. If I don't know if it's easier to understand, but still. Okay. Then the very final thing, the very final Python feature because next week it's going to be about game programming, is regular expressions. And now this isn't a Python feature, uh, as is it's more like its own programming language. And the regular expressions are supported by a lot of programming languages and a lot of other in some other occasions as well. Uh, and the idea of a regular expression is that it's a sort of this language for filtering and searching for strings or for matching strings. Uh, and there's this own syntax which we can use to define the set of accepted strings. So what we do is we write this pattern by using this regular expression syntax, and then we can use it to match for other strings, and we can see which strings sort of satisfy the conditions we set in this pattern. And for the most simple regular expressions, that they can probably be at least sort of easily be implemented with just standard Python string operations. But the more complex regular expressions are really difficult to feed or implement with standard string procedures, because you can do really complicated thing with regular expressions. Now the thing about the regex, which we usually use to shorten it, to discuss or talk about regex, is the thing about regex is that the syntax is pretty awful. To I think that's a correct word to describe it. It's difficult to understand. People sometimes call it read-only programming language. Sorry, write-only programming language, because you can write this, but you can't really read them. It is of course possible to understand them, but they can be, especially if they are a bit more complex, they can be really sort of difficult to understand. Another thing about regex is in practice is that if you want to create something more complicated, and today we of course going to practice writing these like simple ones, but if you want to create something more complicated, it's for example, if you want to like validate an email address or something like that, then just Googling for existing regex is a good idea, or LLMs. Lots like AI tools are quite good in defining at least some of the simple regexes, and sometimes even the more complicated ones. But let's go through some of the basic syntax to give you an idea what you can do with this. And for this, I rewrote this simple code. What it does, it creates this pattern in here, and then it queries for strings, and then when we give an empty string, it quits, but then it checks whether the given string matches the pattern we created. And this is, I just did this. We have a similar example in the material, I think, and we can use this to see how the regex rules actually work. And if we start with something simple, the easiest thing is just to keep some characters in here. Uh, so if you just provide some characters without providing any like special control characters, then it means that any string that contains these characters matches. So Python matches or MEF matches, and of course it doesn't matter what is the uh, first character in here, uh, and the basic string ith matches, but if it's something else like Python misspelled, then it doesn't match. So the string needs to contain these characters yt and h in this order somewhere inside it. Now, as I mentioned, this is a really simple example, and doing something like this can be easily done with Python's in operator, as we know. So there's no point in using regex for anything like this. Uh, but we can add some alternative rules. For example, let's now accept both ith and AVA, meaning that in this case we can use both programming language names Python and Java to match for this one, and Lava as well. And any string that contains either of these YTH or AVA will now satisfy this pattern. So these will both work. And of course, we can have any number of these in here. I'm going to show you some other rules quickly just to give you the idea. If you want to have a list of accepted characters, we can have them inside square brackets, meaning that see that we want to accept A, B, C, or R, and S. Oh, now we started with Y. Well, means that YA now works. YB also works. Yes. Or what am I Yes, robot works because no, it doesn't work because there are characters in between. Y robot does work. Uh, and now if it's something else like Y and Z, then it doesn't work. And also if there isn't Y in the beginning, it does not work. Uh, the Y wasn't supposed to be there, but you get the idea. Also, if you want to define a sequence of characters, we can do something like A.E, and then just, well, let's do this one first. So now it accepts any uppercase character between A and E. Bobo is fine. Cat is fine. Uh, David is fine, but something starting with F, for example, is not fine because F is not included into this A. In this list of characters between A and E, like A, B, C, D, E. So again, it's easier to sort of include a bunch of characters if you, and especially if you want to include all the uppercase characters, it's easier to write A to C than list them all one at a time. So this means that it accepts any character or any string that starts with an uppercase character between A and C and then contains the characters. Oh, sorry, I need to restart it. So it accepts hello and cello, but it doesn't accept hello with the lowercase, and it doesn't accept hello because it's missing one L or something like that. And there are a bunch of these rules. Uh, if you want to include a specific number of any substring or any character, we can use these special characters like asterisks defining that there needs to be 0 or more characters, so any number of character, plus means that there needs to be at least one character, and so on. So let's do something like 8. That is too much. Plus, and now there needs to be at least one character between A and E for it to be acceptable. So A is fine, E is fine, ET is fine, but if it's DT, then it isn't. No, it is. Of course, it's fine, but FT isn't fine because there isn't a single character between A and E in the string. And the thing about regex is that you can combine these rules as many as you want in a row, so you can create really sort of a complex rules. And as I mentioned, this is used whenever we need to have a string which follows certain rules. So a typical example is something like that you want to ask the user to enter an email address, and you want to validate that it actually conforts or follows the rules defined for email addresses. Like there needs to be at least one character between before the at sign, and there needs to be the at character, and then after that one there needs to be the web address which contains of the name and the domain probably needs to contain at least two characters and so on and so on. And these are easier to type in as a regex than just to perform all the checks at one at a time. But then again, if you take a look at the syntax, and especially if it gets more complicated, then this is something that this can be really difficult to read this whole sequence. But it is really you can do a really complicated things with this one. It's a really I can't get the word in my mind what I'm thinking of, but it is really powerful language in a lot of senses, but the syntax is just horrible in a lot of cases. And there are rules defined in the material like this. Character means that the match must be in the beginning, and dollar character means that the match must be in the end. So, for example, this expression means that it needs to begin with this Jabba and end with this hut. So Jabba the hut is fine, and Jabba a hut is fine, but Jar Jar the hut is not fine, and so on, so on and so on. Okay, there are a couple of exercises I think about this one, at least one, where you need to practice this and then you probably get the idea of how it can be used. And the basic rule, it's a good idea to remember the basic rules, like what does it mean to just have characters and what do the square brackets means and maybe what do these character means, these characters mean and so on. But I wouldn't worry too much about creating any like more complex rules yourself. It's easy to Google for this and unless you're doing something else, something that nobody has ever done before. But usually you can get around this by searching for just these given sequences. That's it for about the actual topics today. Next week we have one more lecture. And it isn't really a lecture, as I said. This is was like the final actual lecture, but there will be like a short demonstration about how to use the features in Pygame. Well, I guess you can call it a lecture. I will show you some examples on how to use the Pygame, how it works in general. I will also share a bit more complicated example with you, including the source code, something I wrote earlier. And there are some examples on how you can, for example, use classes in Pygame, because classes are in games. Games are a good example on how to use classes in a sense that when you are creating characters in a game, uh, those are naturally objects. Like you have a hero that goes around in game, that's like one object, and then you have the enemies, which are also objects, and so on, because they all have their own properties and own operations on which they can perform and so on. And then in addition, as I promised, I will tell you a little bit about what's going to happen in the final exam. I will show you at least one task from one of the previous exams. Uh, and then after next week, the final week we don't have any lectures, then the final week is dedicated to writing your own Pygame project. So that's it for week 14, and then we're done. I will then the final exam, and then we're done with the course, and you can go on to do something else. So thank you very much again for this one.